Well, good afternoon, all. I hope you can hear me. Maybe give me a thumbs up if that's the case. Excellent. We're going to continue on with the spinal cord injury lecture series, and today I'm going to speak about stem cells and a few other curative strategies for spinal cord injury recovery. This may be a little bit different presentation than what you're used to seeing, in that we're going to be speaking a fair amount about ethics and moving forward with translational research from the bench to the bedside. Talk about some of the basic principles for the Belmont report on research ethics, and then we'll talk about the clinical applications of some, but not all, stem cell research, focusing specifically on spinal cord injury. So why would I do this? You teach best what you most need to learn, and I need to stay on top of, I think, the clinical investigations that we're moving forward with in spinal cord injured individuals. Priorities and agendas are a little different depending on your perspective as you're moving forward. This is an interesting cartoon from some years ago as they were talking about spending money on Mars exploration and whatnot, and certainly there are some things that we need to address in our own world before we move out into the galaxy. I'll share a little bit of my my agenda, my biases. I am a person, a physician, a researcher that wants to invest in ability. Disability comes in many forms, and it can include emotional and spiritual issues. It can include physical and intellectual issues. And, you know, those all differ in terms of their cause, as well as their degree of life quality and life value. So we're going to talk through a little bit of the ethics associated with that. And then I'll be speaking through about stem cell research, including embryonic stem cells, adult stem cells, and autologous stem cell applications. So can't get very far from the research ethics as you move forward with these things. 1980, they talked about the issues of impairments, disability, and handicaps. And just as a starting point, an impairment is loss or abnormality of structure or function. And so the impairment can lead to a disability, which is inability to perform an activity due to an impairment. Whereas a handicap is something that is environmentally or socially imposed as a barrier to prevent folks with impairments and disabilities from fully participating in society. In rehabilitative medicine, we have the opportunity to help individuals optimize their abilities physically, psychologically, socially, vocationally, avocationally, and educationally. And we are advocates for life and abundant life at that. So just a few definitions as we start talking about ethics. Ethics essentially is the process of determining right and wrong. And as you look at ethics, there are a number of different perspectives. Deontological is authoritative, so this involves God and natural law. Teleological is one in which typically we think of utilitarianism, in which the end justifies the means to provide the greatest good for the greatest number of people. Relativistic is based on cultural or personal experiences. This is what we call situational ethics. And it's difficult if we're living in a world with situational ethics, and yet we are having to make some absolute decisions. So bioethics is the discipline of dealing with ethical implications of biological research and applications, especially as we look at medicine. So just going back a little ways, as we talk about folks with disabilities and balancing life value and quality, often life value is minimized for the most vulnerable in our society, and that can be based on race, gender, age, and yes, disability. In fact, if you wanted to come to America back in the day, several hundred years ago, you had to demonstrate that you were sound of wind and limb. This was required for emigration to America. State laws were put forward in the 1800s, including involuntary sterilization for individuals with disabilities. And there was the Compulsory Education Act of 1860, which banned children with disabilities from participating in public school settings. So what has investment looked like over the years? We started to reassess things in the United States, at least, with the Soldiers' Rehabilitation Act of 1918, when we had a number of folks returning from World War I with some significant new impairments and disabilities. Subsequently, this led to the Civilian Rehabilitation Act of 1920, in which we started to look for ways, and particularly within the VA, of trying to rehabilitate and find devices, biomedical devices, to help folks reintegrate into the community. The GI Bill of Rights was put forward in 1944, again, tied to one of our world wars, and that led to Vocational Rehabilitation Act in 1954. The Civil Rights Act of 1964 really didn't seem to have much impact on persons with disability. And it wasn't until the Rehabilitation Act of 1973 that we started seeing advocates and advocacy for persons with disabilities. I remember, maybe not the rest of you, but I remember in 1975 when the Education for All Handicapped Children Act made it mandatory for public schools to provide accommodations for children with disabilities. And yes, I had graduated from middle school at this point, and hadn't seen but two individuals that I can recall who had had disabilities at that point in my education. The Americans with Disabilities Act came forward in 1990 and has gone a long ways, but actually fell somewhat short of what we had hoped for. There are a number of champions for balancing life value and quality of life, persons with disabilities, including Helen Keller, FDR, Stephen Hawking, and Christopher Reeve. So why are we having this discussion? There was a fair amount of social ambiguity within the United States coming about in the 80s and 90s in particular. And Jocelyn Elders kind of pushed this a little further as she said, America needs to get over its love affair with the fetus. Peter Singer was a Princeton bioethicist, actually the Ira W. DeCamp Professor of Bioethics at Princeton, who said the life of a fetus is of no greater value than the life of a non-human animal at similar levels of rationality, self-consciousness, etc. He really put forward that recognize the worth of human life varies from individuals to individuals, and was a great proponent for utilitarianism, which defines any act that increases the total amount of pleasure or decreases the total amount of suffering in the world as moral. Now, so this kind of leads to a slippery slope, and I'm going to come to media because this really does help us to kind of put things in perspective over the years. In response to Dr. Singer's issues with regard to utilitarianism, there was a manuscript put forward in the archives of PM&R in 2003 saying, and this was basically a white paper statement from physiatrists, that we believe professionals involved in physical medicine and rehabilitation should join people with disabilities in demanding that bioethics incorporate basic recognition of universal human rights into its underlying values. A huge, huge statement. And surprisingly, the first from any of the medical communities with regard to persons with disabilities. Now, Hollywood ethics, you can go back and look at some of these movies, very, very interesting. And I'm not going to spend too much time on them other than to say that they would be interesting for you to, if you've not seen them, to look back at them. All the way back to Coma in 1978, Clint Eastwood's $1 Million Baby, which actually it has a dual purpose with regard to that title. I won't go into it. October Baby, and then Me Before You in 2016. So the whole point of this is that we need to take a look at life value, recognize that some of the most super things that have occurred after spinal cord injury, for example. Christopher Reeve's heroics after Superman. Joni Eareckson Tada, who, so this is one of my heroes as I was growing up. She had a C5 Asia Impairment Scale A tetraplegia after a 1967 diving accident in the Chesapeake Bay. This young lady has written 35 books and has established Johnny and Friends, an international organization that provides wheelchairs and equipment to particularly children across the world who wouldn't be able to have them otherwise. She's extensively traveled 41 countries and openly says, my life would have been completely different and probably not as valuable if I hadn't had my spinal cord injury. And it just gives you pause for a moment. Recognize that there are over 43 million individuals in America with a disability of some sort, including mobility impairments, acquired brain injury, hearing impairments, vision impairments, psychiatric disability, intellectual disability, and then others. And they kind of break down as I show here. So I'm gonna yes, step back into spinal cord injury for a little while, just to recognize that as we think about spinal cord injury, we think about the somatic involvement, sensory and motor deficits associated with different levels of spinal cord injury, as well as the autonomic dysfunction that comes along with this. Now remember that the cord is about the size of your little finger as it passes through the neck, and then it varies in size as it goes down towards the rest of the body. And the cellular components within the central nervous system, brain and cord, include 10% of the total mass is actually nerve cells conducting electrical impulses, but 90% of the cord, the spinal cord, for example, is not neurons, but in fact glial cells that support and nourish and insulate and protect the neurons. And these cell types are nonetheless put together early on in the developing fetus. The central nervous system grows during this time incredibly, so that the cord is already connecting everything to the brain, to the limbs, to the viscera, and all of this is happening very, very quickly as the central nervous system develops over a period of time. And we can detect brain waves at 5.5 weeks into the fetus's development. The cord, nonetheless, is incredibly complicated as the fetus is growing and those neural networks are developing. Recognize that they are already partitioned off and insulated from each other so that you don't have inappropriate crosstalk. You have information descending from the brain to the rest of the body and information coming in from the rest of the body and going back up to the brain. And all of that is packed in these tight bundles so that there isn't inappropriate crosstalk between them. And so we have these descending tracks going from the brain to the body, ascending tracks, body to brain. We have peripheral nervous system coming in at about 1 centimeter intervals and information going out at about 1 centimeter intervals. We call these the dermatomal or myotomal distributions. We have interneurons that can be facilitatory or inhibitory also in this. And this is a very simplistic cartoon nonetheless. An injury to the cord is going to damage all of these pathways or most of these pathways. And so what are the steps to a cure? And this is the wonderful logo from the Miami Project to Cure Paralysis, is to be able to provide hope, but also to specifically look at what is the process to be able to provide a cure for spinal cord injury. And they've identified within the Miami Project patient selection and retraining as part of this, surgical intervention and neuroprotection, transplantation and regeneration may be necessary, overcoming these barriers for regeneration and then rehabilitation. What are those barriers that we're talking about? So very soon after a spinal cord injury, I mean, you have your primary damage and your secondary damage, but then within a matter of weeks and certainly months, you develop a glial scar around the area of damage, which is essentially necrosed tissue. And so a lot of that is just dying cells now leaving a gap if you will, in the cord itself. And so we could potentially traverse that gap by putting in stem cells or Schwann cells, other types of cells, or a scaffolding to allow neurons to go across there. But you also have a number of inhibitory proteins as a result of the spinal cord injury, the no-go proteins, myelin-associated glycoproteins, tumor necrosis factor alpha, nuclear factor kappa B. All of these are inhibitory proteins to the normal growth of neurons if they were to traverse this. So perhaps we can find a way to limit or inhibit these inhibitory proteins. But even so, if we were to do that, in order for a neuron to grow and develop appropriately, it needs to have specific growth factors provided at specific times in the neural cell's development. And somehow, if we could do that, if we could put together a cocktail and inject that into the area, we would still have difficulty directing those neurons, the new growth, to appropriately connect with neurons above and below. And the problem is, if they don't communicate appropriately, you're going to have the crosstalk that we were wanting to avoid, and the likelihood of spasticity, neuropathic pain, and other problems going on with that. So there have been studies conducted over the years, actually starting all the way back in 1910 and moving forward. But looking at cats and spinalized cats, if you hold their tail up, can walk on a treadmill and start doing this reciprocal gait. If you change the speed of the treadmill, it will also, this is a spinalized cat. This is a cat who has essentially tetraplegia, if you will. And yet we can tie into those, as I discussed last week, because of the aspects of neuroplasticity. Oops, now I'm trying to get past my, there we go. We can also apply this in humans. And so this is Susie Harkema back in the day when she was working in Reggie Edgerton's lab at UCLA. She's now at the University of Louisville. But working to activate what we call these central pattern generators within the lumbar cord. And what we're doing is trying to tie in these reflex pacemaker cells to reciprocally provide gait as you're going through this. And this is going to require some neuroplasticity within the CNS, whether that's reorganization within the brain and cord. You're looking for new ways or new neural connections to compensate for the cord injury previously. So neuroplasticity can include rewiring the existing pathways. It can include facilitating reflex activity and modulating those central pattern generators, or it can promote cortical and spinal reorganization. The other thing that goes along with this, exercise has a lot of benefits to it. And so being able to perform rehabilitation improves cardiovascular and pulmonary function, autonomic and neuromuscular function, retards the aging process, and prepares the body for curative interventions. So worst case scenario, exercise can still be a good thing. But we're looking for a cure. We're looking for a cure for spinal cord injury. What steps have been made to move that forward? So a number of strategies I mentioned previously: neuroprotection, so early on after the spinal cord injury, promoting growth of appropriate neurons through that chasm, bridging, remyelination, and then rehabilitation and exercise. Now, the International Campaign for the Cures of Spinal Cord Injury Paralysis, ICCP, is a group of physicians, scientists, government agencies, non-government agencies, pharmaceutical and biotech companies that have put together a framework of what is recommended for future spinal cord injury trials. We've got a relatively few number of persons with spinal cord injury, thank God. But for those folks who have an injury, they're trying to make decisions about, am I going to participate? Should I participate? What have I got to lose if I participate in these clinical trials? And so as we talk through the stem cell therapies, recognize that if you're talking from the get-go, basically, your sperm oocyte come together and make an embryo, and the embryo goes through its changes to become a morula, blastocyst, and then ultimately you have specialized cells that come out of this, and initially pluripotent, so cells can take any number of directions as they grow and mature, and then they become unipotent, where they will only move into one cell line as you move forward. So I just want to remind you that that embryo meets the biological definition of life. It's a genetically unique human being with a full complement of adult chromosomes from father and mother. It's highly ordered with genetic roadmap for development prior to its first cellular division. It takes energy from its environment, responds to its environment, adapts to its environment, develops complex organs, and contains genetic material required for reproduction. So this is the beginning of human life as we go through the whole spectrum of human life. So as we talk about undifferentiated stem cells, recognize that you've got cells at different parts of the development. If you look at a 5 to 7 day embryo, those cells are what we call totipotent. They can become any number of different cell lines as we go through there, and will create the human being. The embryonic germ cells are pluripotent. They can develop certain categories of cells as they move through the maturation process. And then you have fetal tissue stem cells that may be pluripotent or multipotent. They take cord blood from that is pluripotent or multipotent from the umbilical cord of infants and save that. Adult stem cells are pluripotent or multipotent, depending, and then you have the likelihood that these can become teratocarcinomas, that is certain types of tumors that are pluripotent. That's the problem with getting a cell line that has not completely dedicated itself to become a specific type of tissue. So what we know is that at certain points there are multiple cell lines possible, and then you can also develop unipotent stem cell lines. So for example, bone marrow can turn into some very specific cells. OEGs, we're going to talk about skin cells. And have I mentioned in my lectures fat, adipose tissue, that can also be used to produce actually neuronal cells and cell lines as we go through that. So these unipotent cell lines are basically only going to become one particular cell type. And we can look at that as we're going through there, but looking specifically for nerve cell development as we go through there. So there is a lot of in vitro fertilization clinic storage. You know, there's about a 3 to 10% success rate with IVF to grow children. Those additional embryos are preserved as spares, and we have approximately 400,000 embryos in storage at this point. It requires a parent's informed consent for the embryo to be used for research. The alternative would be for the embryo to be used for adoptive implantation. I'm not going to go into the aborted fetuses. I feel pretty strongly about this, if you haven't picked up on some of this. But there has been work going on across the world, not in the United States per se, but in several areas. And these were felt to be appropriate for research because these individuals were slated to be destroyed. So essentially, instead of becoming a human child, we are taking away that opportunity. So I want to talk about stem cell sources other than the developing embryos. So placental tissue and umbilical cord blood we've talked about before, and then these others, including fat cells, which actually is looking fairly fruitful as we move forward. There have been a number of stem cell treatments for diabetes, for example, and so transplanting the stem cells to the pancreas, and particularly into the beta cells, to be able to produce insulin has occurred both in animal as well as humans as we're moving forward. There is stem cell treatment for cardiac tissue repair. So a person who's had a heart attack and actually an infarction where you've actually got dead or dying cardiac tissue can be replaced with stem cell treatments, and it will actually grow new cells, myocytes, these myocardial cells that will, like all the other cells of the heart, depolarize and allow for contractility. So again, great applications and opportunities moving forward. Parkinson's disease, so there has been going for some time. In fact, way back in my internship, I remember managing a patient, so this is 30 years ago, who had Parkinson's and had gone to Mexico to get fetal cell transplants. And basically they put this into the zones within the brain that basically will replace what has been lost in terms of dopamine, et cetera. So they use CT-guided stereotactic neurosurgery to place these in there. And then they need to provide immunosuppression as well. So as with any other transplanted tissue, this can cause graft versus host disease, et cetera. So over the years, they have continued to modify these trials, and things are actually improving. But there are a number of issues that were posed way back in the 90s and continue to raise concerns about the ethics. And so I think I want to transition into spinal cord injury, recognizing that there's been a fair amount of preclinical work that has been done over the years around the turn of the century. And some of this great work actually done here with the folks in the Miami project as well. As they've moved forward from animal models and start to look towards application in humans, there have been some fruitful studies. Basically, we're going to have to talk through phase 1, phase 2, phase 3 clinical trials, but to recognize that there are some opportunities for stem cell management in spinal cord injury. Now, that said, and this is probably my most controversial slide, man is not a rat. Some people would say that's not the case, but let's just say there is a significant difference in the central nervous system of a rat and a man. It's about 10 times longer in humans than it is in rats. The immune system is significantly different, with a rat's lifespan varying from 18 to 36 months. And recognize the rat model is amazingly immune to infection. Do they have some sort of a diminished graft versus host disease? Yes. And there's an accelerated healing process in rats and mice for that matter. There are stem cell differences in that in humans, there is a greater likelihood of exiting the usual cycle and becoming teratogenic. Humans are more likely to cease after 100 doublings. And then there's the issues of quadruped versus biped in terms of rehabilitation. Rats actually initiate their ambulation with their front limbs, and that helps to set off the central pattern generators in the hind limbs. Now, this same type of work and these discussions were being had here at the Miami Project. Again, back in the 90s, Blair Clancy was an investigator here. He's, I think, now up at Syracuse, but looking at opportunities to activate the central pattern generator in humans. So there have been some work, preclinical work that was done back in 2005. And I actually had the opportunity to have Dr. Kierstead come and do a presentation at the AAPM&R during this time. Basically, that work has moved forward into a clinical trial, but it's taken a lot of time. And that's one of the things that I want folks to recognize. Once you demonstrate this in animals, there is a fairly large leap, and you have to build a bridge of how you're going to do this in humans. And so this particular, so looking at the previous slide, recognizing that it's been moved forward into a phase 1 clinical trial, this work has been completed and reported out as being safe and efficacious. If you inject this into the site of injury within 1 to 2 weeks after spinal cord injury. And so this work is still being translated into phase 2 trials. I'll talk you through phase 1, phase 2, phase 3 trials in just a moment, but recognize that they have cleared FDA approval in the United States for these particular trials. This is the phase 2 trial, again, of those CNS stem cells that we had talked about previously. SkyStar is another bit of preclinical work that is moving forward, looking at application within 14 to 30 days after the spinal cord injury. And again, these projects are just getting off the ground, even though we've been working at this for well over a decade or two. There is a recent publication from the Mayo Clinic proceedings in a different trial. This one is interesting. Again, it uses autologous adipose-derived mesenchymal stem cells in the treatment of paralysis due to traumatic spinal cord injury. They call this CellTop. And this is just one subject. As they're doing their phase 1 trial, they reported out injecting 100 million of these adipose-derived mesenchymal cells into, and they actually just put it into the cerebral spinal fluid. So they did a lumbar puncture. They didn't try to put this into the area of the spinal cord injury. But what they did show, there's no adverse events other than a headache on the second day. But over the next 18 months, the individual had done well and actually had improvements in a number of different things, motor scores, sensory scores, and as they put those together. So, you know, there is hope and opportunity. Olfactory and sheathing glial cells have been used for the last, I'll say, 15 to 20 years, and initially described by Doucette. So these actually are the precursors for your olfactory nerve, that first cranial nerve, and they lie just underneath the frontal lobe and above the cribriform plate. They actually grow through that to become your first cranial nerve. So what we've found over time is that you can harvest these cells and put them back into the same individual. You don't have to worry about graft versus host disease. But these particular cells are felt to be, they have multipotent precursor and stem cells in them. And so as you go in, you collect a centimeter squared of this, you mince it up, and then they actually are taking these immune privileged cells and injecting them back into the area of the spinal cord above and below. So Carlos Lima had been doing this since 2001 in Portugal. And basically his protocol, as I said, included harvesting 1 to 2 centimeters squared of this olfactory mucosal, cleaning that, cutting the fragments, preparing the donor site for the spinal cord injured individual, and then implanting these mucosal fragments. Now this is non-peer reviewed. It came out and was presented actually as a manuscript in the Journal of Spinal Cord Medicine. What had been reported in conferences for approximately a year prior to the actual publication was 26 individuals. What was reported in the manuscript was 7 individuals. And again, they showed, it's like they cherry picked the best folks and the best outcomes as they put these together. But I guess I would just have you recognize that in some cases you had changes in pinprick sensation, for example, where the standard deviation was significantly greater than the mean itself, meaning that you had some bad outcomes as well. One subject was reported to have experienced sensory loss, but otherwise in the manuscript they said that there were no adverse events. What they didn't say was that these folks were, many of them, subjected to 3 hours a day or more of locomotor training when they returned to the United States. So then we don't know how much of this is due to actual injection of the OEGs, or perhaps untethering during the procedure itself, or was it just the locomotor training itself that helped to improve function? So there was another trial going on at the same time. Dr. Wang, an MD PhD out of China, was using fetal olfactory and sheathing glial cells, and basically had reported on 139 men and 32 women, but there was a fairly large range in age, with a mean age of about 35 years old, somewhere between 6 months and 18 years after the spinal cord injury. And what they would do is do a block laminectomy, inject 500,000 of these fetal olfactory and sheathing glial cells above and below the spinal cord injury, do a tight dural closure, and then they would look at, and their outcome was simply the ASIA examination at 8 weeks post-intervention. And these were the findings as we put these out there with regard to motor function, and they broke it down by age range, pinprick, and then light touch. And again, there were some improvements reported, but in some cases, standard deviations were greater than the actual mean improvements as you go through there. So reportedly, oops, I'm sorry, they had done over 1,000 patients to date with more than 50 Americans. This is a protocol that people actually had to pay to participate in, and they didn't keep track of what type of rehabilitation these individuals had after the protocol. So as we look at olfactory and sheathing glial cells, stem cell trials, there continue to be concerns and controversies. Have we had an appropriate preclinical foundation for some of these trials? ICCP has helped us to characterize those more carefully. What is in the implanted cells? What kind of a recovery curve is expected for functional outcomes, and then longitudinally, what could be expected? What are the mechanisms for improvement? So if you have olfactory and sheathing glial cells, why would that help to improve nerve conduction through there? Is this truly ready for prime time? And then additional questions. So I was having patients ask me back before the turn of the century, should I participate in these trials? And so we would have to have the discussion about what is a clinical trial, what is the potential risk, benefit, et cetera. And I was working my way through that. How do I have those discussions and still maintain a good relationship with the patients? Basically, it comes down to caveat emptor, let the buyer beware. And then as a clinician, should I be concerned about my patients who maybe went to Portugal or went to China and then came back, and then if I'm seeing changes in clinical function, should I be reporting that? And if so, to whom and how should that be done? So how do we decide what is ready for clinical trials? There are a number of clinical trials, again, started around the turn of the century, looking at fetal cell transplants, porcine neural stem cell transplants, the olfactory and sheathing glial transplants, stem cell transplants, and then genetically modified autografts. So as we look at these, again, how do I decide what's ready for a clinical trial? So I want to go back for just a moment and talk about some of the research ethics. that we have experienced, especially in the United States, but across the world. The Tuskegee syphilis trials, inappropriate use of Black males who were known to have developed syphilis and weren't provided appropriate treatment when it was an option, weren't told that there was an option. We can't allow that to happen anymore. The Nuremberg trials, where basically they had 23 German physicians on trial for crimes against humanity. They reported that basically these individuals were slated to be destroyed anyway, so we may as well get some good out of it. And hopefully we've moved beyond that now. Thalidomide trials in the 1950s. This is a sedative that was used, it was felt to be safe for mothers, but during that stretch in the 1950s and 60s, there were quite a few infants born with arrested limb bud development, and so essentially auto amputation. And so we saw a number of these children, and I managed quite a few of them as I was going through residency. I don't know how many are still surviving, but recognize that not all research and not all medications are good for us, and we need to know those effects going in. The National Research Act of '74, the Belmont Report of '79, and then the Common Rule of 1991 hopefully keeps us from repeating these mistakes. So most of you have heard of the Belmont Basic Principles. This is to ensure that as we conduct clinical research, we demonstrate respect for persons. We provide beneficence, first do no harm, and that we do things justly and appropriately, making sure that there's equitable distribution or opportunities to participate in research. So taking these one at a time, starting off with respect for persons. This requires that we provide informed consent to the individuals, including providing them the basis for a trial and describing the risks and benefits clearly and completely. Recognize that there are vulnerable populations desperate for a cure. And for those with disabilities, particularly physical disabilities, will participation in this trial preclude my participation in another trial that might come up and look much more promising? Likely to cause harm to an embryo, fetus, or infant using stem cells? And are we providing false hope? So all of these need to be considered as we talk about respect for persons. The risk versus benefit needs to be considered, and is it, if we're talking about benefits, functional, probable, or possible? And is it likely to provide benefits to the society as a whole and or to the individual who participates? We need to definitely describe the potential risks, including a worsened neurological status, potentially shortened lifespan, compromised residual function, and then recognize that there may be additional adverse outcomes that would prevent persons from pursuing an abundant life. If we're going to talk about these biologics, using these stem cells and whatnot, recognize that there is, as I mentioned before, an entire process that has to get the blessing of the FDA. So this process includes phase 1 clinical trials, looking at preclinical testing, what's been done in animals, what as the research and development showed to date, and a safety review is essentially this phase 1 clinical trial. Phase 2 clinical trial, now we're wanting to see how effective this potential intervention is going to be, and to make sure that at least in the short term, things have been safe moving forward. And then the phase 3 clinical trials require, yes, successful completion of phase 1 and phase 2, but now allow us to look not just at safety, but also the appropriate doses and effectiveness of whatever this device or biological process is. So there's, in fact, the Center for Biologics Evaluation and Research, CBER, and they provide guidance for cell transplants, including how are the cells collected, how are they cultured, how do you bank those cells, and then what material is used during the manufacturing and dissemination as you move forward. So translating preclinical to clinical trials, basically the recommendation is, and this is from the ICCP, as well as NIH. We need to replicate those animal models that have been demonstrated to be functionally of benefit, determine clinically relevant endpoints, including what are we deciding on in terms of our functional motor or sensory outcomes. We need to demonstrate compelling and mechanistic evidence for improvement. Why is this working? And then demonstrate safety and minimal adverse events. Those of us taking the Hippocratic Oath do swear to first do no harm, but we need to take a look at toxicity, biological contamination, and then these potential other adverse events as we go through there. And then justice. We need to make sure that the individual has the opportunity to fairly be included or at least not excluded unless it would be of detriment to them or the trial. There should be equitable distribution, including those who are economically disadvantaged, and participation of women and children. And then the legality always needs to be kept in mind as we think about moving forward with these clinical trials. So the ICCP I mentioned earlier, the International Campaign for the Cures of Spinal Cord Injury Paralysis, basically put together a 20-page pamphlet for patients or folks who were considering experimental treatments for persons with spinal cord injury. And again, this was put together by a group of researchers, clinicians, pharmaceutical agencies, and others that are listed on this. And essentially, that 20-page pamphlet says, here's what you should ask as a potential subject. Is this clinical trial going to be safe? What are the possible benefits? Is there preclinical evidence to support its benefit? Is this a clinical trial or just a pseudo trial? What is specifically the protocol? And will it preclude my participation in other trials? Is this going to cost me? And or am I going to be reimbursed for certain things? And then you should try to get an independent assessment of the intervention and the investigators. Is this Dr. Gator just some quack who's doing this off the top of his head and is making a profit by it? Or you know, is there legitimate research and that's been under peer review? So my concluding points, and I'm running through this fairly quickly, but I think I'm about on time. Persons with disabilities are valuable members of our society. We need to treat them as such. Stem cell research is a developing science that does hold promise for persons with disabilities. I think specifically we should be looking to adult stem cells. They can be pluripotent. They can allow for selective differentiation and controlled growth. And they're available from several sources that don't jeopardize a human life or fetus. Spinal cord injury repair is probably going to take a combination of interventions. Stem cells may play a role in that. And then we need to try to ensure that these clinical trials are judicious and carefully planned to optimize benefit, minimize risk, and respect the persons involved. For the Miami Project to Cure Paralysis, and one of the reasons I came here to Miami is I appreciate what the process leading to a cure for paralysis involves. The preclinical work, the very safe and cautious progression of phase 1 to phase 2 to phase 3 clinical trials. Recognize that spinal cord injury repair and regeneration has been demonstrated in animal models with certain interventions. And yet there remain barriers to a cure. And yet those barriers are being broken down both at the animal as well as the human level with the continued work. Efforts and support are available through the highest level of NIH and private foundations, such as the Bonacotti Foundation and the Miami Project to Cure Paralysis. And yet, as we move forward, health remains paramount for survivors of spinal cord injury in order to be able to benefit from a cure, should a cure actually be found. And so, learn from yesterday, live for today, hope for tomorrow. And I don't know who to attribute that to, but it's a great quote. I've been very fortunate over the years to be funded in a number of different ways, and I'm acknowledging that support here. I want to leave plenty of time for questions. This is probably one of my more, well, there may be conflicts, and I'd certainly be welcome, or I'd certainly welcome any additional questions or discussions.
Hey, David, Jim here. Can you hear me?
Yes, I can, Jim. Thank you. I was hoping you would show up because you've got a great perspective on all of this.
I really enjoyed your presentation, and I really think that the whole stem cell research thing is very important from ethical positions. There were 4 little things I wanted to mention. One is that induced pluripotency may help us get around the whole need for fetuses. And so that's gone pretty far. So it's really amazing that you can have a fibroblast that can be dedifferentiated back to become essentially an embryonic stem cell. Some work has been done already in retinal repair with those cells derived autologously. And so the other issue is whether you can get around the immune suppression with them. Yeah. As much as we want mesenchymal stem cells to become neurons, it's not entirely clear that they become truly functional neurons. They can take on some of the properties of neurons. With the olfactory mucosal transplantation, one of the things I wanted to bring up is that in that series, and in fact, those were done all over the world, there are now 2 reports of spinal cord tumors that grew because they transplanted mucosal cells. And so that brings us to how important the regulation of the cell product is. And then for the Huang trials of so-called olfactory and sheathing cells, we went there to Beijing and we published 2 papers. One of the things that we found is that the cells were not actually olfactory and sheathing cells. They were some type of neural stem cell, but they were being grown from tissue that was very difficult to understand. So I really like everything that you said. I just wanted to bring up those few points.
I appreciate that, Jim. Your expertise, obviously, and the years that you've been conducting research, I've very much appreciated. I actually had Dr. Wong come to a AAPM&R meeting that was held in Hawaii around 2005, and Bruce Dobkin was there and had an opportunity to work with some of the folks who had been involved with that trial who had lost function, and actually they broke out on the platform of I was literally trying to separate people. Feelings were that intense, as Dr. Dobkin was saying, we have found these things and we're going to publish what we've found with these folks who went to China, received this, and have come back with deteriorating function. So it's going to continue to be controversial, but again, I appreciate all of your efforts. I'm certainly not an expert in this particular area, but I've got skin in the game because my patients continue to ask, what should we be doing with this? And obviously or maybe not so obviously, one of the main reasons I'm here in Miami is to work with the Miami project, because I appreciate the integrity and the ethics that everybody functions with. So thanks again. Any other questions? Thoughts, concerns? Jim, it sounded like you were about to speak again.
Yeah, I would just like to say that we are making a lot of progress with stem cell transplants. One of the real assets we have here in the United States is the California Institute for Regenerative Medicine. And so I guess what I would call state of the art is to take the induced pluripotency cells and differentiate them into specified neurons or specified neuron progenitors that can survive transplantation. And I think basically for cells to work, we need to be able to recreate circuits. And so there is a lot of randomness that goes along with these transplants. So as we get better control of the circuit formation, I think we'll see better results. That's what I was going to say.
Thanks. Yeah, I appreciate that. Any additional thoughts, questions, comments? Again, this is not my area of expertise, but it is an area that all of us need to at least be aware of and try to keep up with as we're moving forwards to try to provide the best life and best possibilities for our patients with spinal cord injury. So thank you all for your attention and for your ongoing work in this area. Hope everybody has a great day.